In this video, we will be going over how you can solve systems of linear equations with two variables using the substitution and elimination methods. Let's jump right in. So generally, when you're given a system of equations, it'll look something like this. You'll have two or more linear equations, and you'll be asked to solve for an xy pair that satisfies both of the equations. Now, there are multiple ways to solve these types of systems, but let's start off by using the substitution method. So for this first problem, we have the equations of two lines. Y is equal to 2x plus 7 and y is equal to negative 3x plus 2. So both of these lines are in their slope-intercept form. Now solving this first system is actually pretty easy. We know that y is equal to 2x plus 7, so we can substitute 2x plus 7 for y in our second equation. So if we do that, we get 2x plus 7 is equal to negative 3x plus 2. Now our equation is just in terms of x, so we can solve for x. If we add 3x to both sides, we get 5x plus 7 equals 2. And now if we subtract 7 from both sides, we get 5x is equal to 2 minus 7, which is negative 5. Now if we divide by 5 on both sides, we get that x is equal to negative 1. So now we know that x is equal to negative 1 when both of these equations are satisfied. And we need to find the corresponding y value. So to do so, we plug in negative 1 for x in one of these equations. So if we use the first one, we know that y is equal to 2x plus 7. So when x is negative 1, y is 2 times negative 1 plus 7. So negative 2 plus 7, which is 5. And so the xy pair that satisfies this system of equations is negative 1, 5. Now graphically, what does this point represent? Well, if you were to plot these two lines on an xy plane, then they would intersect at one point, and that point would be negative 1, 5. So the solution to this system of equations can also be interpreted as the point of intersection for the lines in the system. Alright, now let's move on to the second problem. We're given the equations 2x plus 5y equals 8 and x minus 3y equals 4. So in the first problem, we were given the lines in slope-intercept form, but now we've been given them in standard form. Now, to solve the system, we're going to need to isolate one of the variables, and we can easily isolate x from our second equation by adding 3y to both sides. If we do that, we get x is equal to 3y plus 4. Now we've solved for x in terms of y, and we can substitute this solution into our first equation. So now looking at our first equation, we know that 2 times x, which is 3y plus 4, plus 5y equals 8. So if we expand this term out, we get 6y plus 8 plus 5y equals 8. Now if we add like terms, we get that 11y plus 8 equals 8. And then if we subtract 8 from both sides, we get 11y is equal to 0, which means y must be equal to 0 as well. Now we know y is 0, but what's the corresponding value of x? Well, we can use our substitution to solve for that. We know x is equal to 3y plus 4, so when y is 0, x is going to be 3 times 0 plus 4. So 0 plus 4, which is 4. And so, the solution to this system of equations is 4, 0. And so once again, if you were to graph these two lines, their point of intersection would be the solution to the system, so the point 4, 0. Alright, now let's move on to our final example. We have the equations 5x minus 4y is equal to 10, and 3x plus 6y is equal to 6. Now, once again, we're going to have to isolate one variable, and I think of all the options, isolating x from this second equation will be the easiest. So we're going to subtract 6y from both sides, and we get 3x is equal to 6 minus 6y. Now we want to solve for x, not 3x, so we're going to divide by 3 on both sides, and we get that x is equal to 6 divided by 3, which is 2, minus 6y divided by 3, which is 2y. So we solve for x in terms of y, it's x is equal to 2 minus 2y, and we're going to substitute this back into our first equation. Now from our first equation, we know that 5 times x, which is 2 minus 2y, minus 4y, equals 10. So let's expand this term again, we get 10 minus 10y, minus 4y, is equal to 10. Now let's combine like terms. We get that 10 minus 10y minus 4y, so minus 14y, is equal to 10. And if we subtract 10 from both sides, we get that negative 14y is equal to 0, and so y is equal to 0 as well. Now, we need to find the corresponding value of x, so we're going to use our substitution once again. We know that x is equal to 2 minus 2y, so when y is 0, x is 2 minus 2 times 0, which is 2 minus 0, so 2. So the solution to this system of equations is 2, 0. Okay, so the basic idea for substitution is pick one of the equations and isolate one of the variables. So solve for that variable in terms of the other variable. Then plug that substitution into the other original equation, and from that point, it should be pretty straightforward to solve the system. Now let's move on to the elimination method. So, like the name suggests, in the elimination method, we're trying to directly eliminate one of our variables. And I'll show you what I mean by that with this first problem. So, we have two equations, 2x plus 3y equals 4, and x minus 3y equals 2. Notice that we have plus 3y here and minus 3y here. So if we were to add the two equations, so set the sum of their left-hand sides equal to the sum of their right-hand sides. If we were to do that, the plus 3y and negative 3y would cancel, and so we would be left with 2x plus x equals 4 plus 2, which is 6. And so we get that 3x is equal to 6, and if we divide by 3 on both sides, we get that x is equal to 2. So now we've solved for x, and to find the corresponding value of y, we're going to plug in this value of x back into one of our equations. So let's take the first equation for instance. We know that 2 times x, which is 2, plus 3y is equal to 4. 2 times 2 is 4, so 4 plus 3y is equal to 4. And if we subtract 4 from both sides, we get that 3y is equal to 0, which then means that y is equal to 0 as well. And so the solution to this system of equations is the point 2, 0. Okay, so that elimination was really straightforward. Now let's move on to the second example where things get a little bit more complicated. So here we have the equation 3x minus 5y equals negative 1 and 2x minus 6y equals negative 6. And now let's say we're trying to eliminate x. If we were to just sum up the equations like we did in the first example, we would get 5x minus 11y is equal to negative 7. And that does us no good because we still have two variables. And if we were to, say, subtract the two equations instead, we would get x plus y equals 5. And that does us no good either. And so we're going to have to manipulate these two original equations in some way, such that the x's completely cancel. And the only way that will happen is if we have the same number of x's in our first equation as we do in our second equation. So if we erase this, so what's the least common multiple of 3 and 2? It's 6. So if we can find some way to get 6x in the first equation and 6x in the second equation, while still preserving the equations, then we can eliminate like we did in the first problem. And the way we're going to get 6x in the first equation is by multiplying the entirety of that equation by 2, and the way we're going to get 6x in the second equation is by multiplying the entirety of that equation by 3. So if we do that, let's start off with the first equation. We get 3x times 2, so 6x, minus 5y times 2, so minus 10y, is equal to negative 1 times 2, so negative 2. And if we do the same for the second equation, we get 2x times 3, so 6x, minus 6y times 3, so minus 18y, equals negative 6 times 3, so negative 18. And now, if we subtract the two equations, we'll be able to eliminate the x's. 6x minus 6x is 0, so the x's will go away, and we'll have negative 10y minus negative 18y equals negative 2 minus negative 18. So negative 10y minus 18y is negative 10y plus 18y, so that's 8y, and that is equal to negative 2 minus 18, so negative 2 plus 18, which is 16. And if we divide by 8 on both sides, we get that y is equal to 2. And to find out the corresponding value of x when y is 2, we just use one of our original equations. Let's maybe use the first one. We get that 3x minus 5 times y, which we found out was 2, so minus 5 times 2, is equal to negative 1. So 3x minus 10 is equal to negative 1. And if we add 10 to both sides, we get that 3x is equal to negative 1 plus 10, which is 9. And then if we divide by 3 on both sides, we get that x is equal to 3. So the solution to this system of equations is 3, 2. Alright, now let's do one final example. Here we have 2x minus 5y equals 7, and 6x minus 2y equals 3. Now, the simplest way to go about this would be to eliminate x. We have 2x in our first equation and 6x in our second equation. So if we multiply all of the first equation by 3, then we'll have 6x in the first equation and 6x in the second equation. And if we subtract, the x's will be eliminated. So let's do that. 2x times 3 is 6x. Minus 5y times 3 is minus 15y, and that is equal to 7 times 3, which is 21. Now the second equation we have as is, we'll just copy that down. 6x minus 2y is equal to 8. So now if we subtract both equations, we get that the x terms cancel, and we have minus 15y minus negative 2y is equal to 21 minus 8. Negative 15y minus negative 2y is negative 15y plus 2y, so negative 13y, and that's equal to 21 minus 8, which is 13. If we divide by 13 on both sides, we get that y is equal to negative 1. Now to find the corresponding value of x, we'll plug in y is equal to negative 1 into one of our equations. Let's use the first one here. So we have that 2x minus 5y, and we know that y is negative 1, is equal to 7. So we have 2x plus 5 is equal to 7, and if we subtract 5 from both sides, we get that 2x is equal to 7 minus 5, which is 2, and then if we divide by 2 on both sides, we get that x is equal to 1. And so the solution to this system of equations is 1, negative 1. So essentially, in the elimination method, we try to directly eliminate one of our variables, and we do so by summing or subtracting our two equations. And if needed, we multiply those equations by some constants such that one of the variables cancel. Alright, that's all there is to this video. If it did help you out, please be sure to leave a like, and if you want to be notified when I post the rest of the videos on this course, make sure to subscribe. Thanks for watching.